Good morning. Yeah, good morning, everyone. So we're going to continue our journey with regular expressions today. So we have done the basics of regular expressions the past 2 days, and this is a good time to look back and see before we proceed on to further topics. Let's say we want to now solve a problem, regular expression. So that's what we'll be doing today. So let's see if there are any questions that we can try to clarify or something. So the past couple of days, so we've had this introduction to regular expressions, and we've tried to construct regular expressions for different tasks. Okay, and so are there any questions anyone has?
Sir, can I ask?
Yeah, please.
Sir, yesterday you at last you gave one problem, no, sir. Out of that pattern you have given, in which we have to find CAT or A
Yeah.
or B. In
Ah.
that, sir, in yesterday's notes you have given other than 5 and 8 like that, no, sir. Answers yesterday.
1 second. Let's just see that. Yeah, I'm just pulling it up. Yeah, here it is. So this is where we were yesterday, and we're going to continue from here. So we have the pattern as C, and then A or
A or
B,
B. Yes,
and then T. We have a star here. The star is a quantifier, and it means 0 or more times.
more.
Okay. All right. So it will match cat, correct?
Yes, sir. Sir, one small clarification, sir. Zero or
Yeah.
more, that asterisk we have kept after that parenthesis, no, sir. So that
Before
is
the
saying,
asterisk, we have the parenthesis. Before the
yeah,
asterisk. Yeah.
yes, sir. So it means that A or B in A or B or both can be repeated any number of times, zero or more times. Am I right?
Yes, you're correct.
Okay, sir. Okay.
So
So
now what? Let's see one by one. Let's go. This may be wrong. This may be wrong. So let's see. Cat is fine, correct?
yes, sir.
So now SCBT. Okay, will this match?
That was my doubt, sir. It is starting with S, but CBT is there after S.
Yeah. CBT will match because we are not saying like caret symbol or anything. If you put a caret symbol, then it has to match at the beginning.
Okay, sir.
This is just CBT, so it will match. It will match the CBT here. It will match this string. That's all. This string will have a hit for this pattern.
Okay.
Okay, and exactly what it matches is this. And if you want to look at the group the group it matches is B.
Yes, sir.
All right. Now what about this?
It will match, sir, because either A or B is not there, but asterisk symbol is there, zero or more.
0 or more. So it's occurring 0 times. So SCT will match because it is just C and T. Okay. Now CAAT,
It will match.
TAAT will match because C, A 2 times and then T. 2 times is permitted by the star. What about CSBT?
No, sir. In between, the
CSBT will
flow is
not match.
missing.
Yeah, the S is missing, isn't it? It's not there in the pattern. So even if the C matches, the C has to compulsorily matches here, but there's no S in the pattern. Now, what about SCABAT?
It will it will match, sir.
It will match, correct?
Yes, sir.
Because now we have C and then we have A, that's fine. Next we have B. B is also fine because it is A or B any number of times. Again A, it is also fine. So finally a T, and it matches the pattern. Everyone is following? Why 6 is matching? Okay. All right. What about 7? Anyone?
It,
7 will match or not?
no, sir.
Why?
C is not there. Only S
C
plus
is
T.
not there. The pattern must have C. C is not there. As simple as that. So 7 will not match. What about 8?
T is not there.
T is not there. That is the problem here. The problem here is that T is not there. So in fact, it is except 5, 7, 8, everything will match. Correct? Is it clear?
Yes, sir.
Yes, sir.
Okay.
Understood, sir.
Yeah, okay, good, good. Okay. So there was just one more quantifier that I missed out here. You've already seen this quantifier, and that quantifier is you've seen this special character, but not as a quantifier. Okay, you've seen the question mark when it is used after the star or plus, it enforces a non-greedy match. Okay, so this non-greedy match is a sort of a advanced concept. You know, even if in the first reading we are not able to understand it, it is fine. But then the question mark as a meta character is also a quantifier. Okay, you can use it after a character directly. And what it means is 0 or 1 time. Okay, 1 time only. So the difference between star and question mark is star is 0 or more times, but question mark is 0 or 1 time only. It's either there or not there. Okay, so that option is available. Okay, so but star is it can be 0 times, no time at all, 1 time, 2 times, 3 times, 10 times, 100 times. Any number of times is fine. But question mark basically means it is present either 0 time or exactly 1 time only. So we can use the question mark as a quantifier. Right after a character, if you use the question mark, it means the preceding character can occur 1 time exactly or it need not occur at all. Okay. So it's either present or absent like that. So for that, we can use the question mark. Okay. There's another function of the question mark when it follows one of the quantifiers themselves. There it enforces the non-greedy search, non-greedy matching. Okay. So yeah, so it depends on how the pattern is constructed. Now the language, how we parse the language, depending upon the pattern, the question mark meaning will become clear, depending on the context. If it follows the character, it has this meaning. If it follows a quantifier, the question mark means it's a non-greedy search. That is the only extra quantifier that we missed out. I've added it here. And yeah, all right. So any other questions, anyone? So we are done with this as well. So anyone, any other questions with regex, what we have done so far? All of you are ready for a problem now, a proper problem in regular expression?
Sir, actually, I have a doubt.
Sure.
So yesterday when we were extracting the strings from mail, we wrote
Yeah,
the pattern and it returned in a tuple, right? There were different types of patterns which has been extracted. At the end, we had 0.
right, right.
What is that 0, sir?
All right, so let's go back. Okay. Right. So you mean this 0 and this 1, correct?
Yes, sir. That's 0 actually. After 2020.
Yeah. It's doing something. It's a 0 here, it's a 1 here, and it's an empty string here. We're getting all these correct as a extra element at the end. See why. All right. Now this 0 here is basically it is matching. You have a inner parenthesis here, correct? Let's just talk about this particular 0, and let's see what is happening here. Backslash. So it is trying to return what is matched here. And so you see we have 3 parentheses here. So there are 3 groups to be returned. For the first one, it is returning the email address here. For the second one is this entire pattern, what is following the email address, and that particular date time stamp is being returned. Okay, so it's a dot star and then some numbers, and that is being returned. So that is fine. And when we look at the pattern here, you see the last number is what is being matched here. Okay, so because you see this dot star is a greedy match, so it basically matches everything till 202. Okay, and then the last 0 is matched for this particular parenthesis. Okay, because the dot star is a greedy match, and only the last one needs to be satisfied by this match, and that happens to be a 0 in the 2020, and that 0 is produced here. But then that 0 is also a part of the larger pattern, so the entire pattern is produced for the second group. But the third group is just a 0. That is due to the greedy behavior enforced by the dot star. You're able to follow?
Yes, sir. Yes.
Okay. Now, when we do this second one, since we put a space here, the only thing that is matched is before the 2020, because it stops at the space, and therefore this is what we have. And here, if you look at the last number, again, it's a greedy matching for the dot star. It matches till the 0 here. Okay. And then the 0 to 9, this particular pattern, this group that we have here matches the 1. Okay. And therefore, that 1 is returned here as the third group, because that is the third group here. You're able to follow?
Yes, sir. Got it.
Okay. Now here you see we are doing a non-greedy match. And since we are doing a non-greedy match, you don't get anything at the end. So the last bracket is not matching anything. All right. So this is the meaning of the 0 and the 1. It is the third group that we are matching within the parentheses. So this is here we have 3 parentheses, of which 2 are nested. We have a nested parenthesis here. So there is an example of nested grouping. Okay. So we have one parenthesis here, another parenthesis here, and then we have a nested parenthesis. So in fact, there are 3 groups, and find all will return all the 3 groups. And we can also use the dot group method of a search object to retrieve all these groups one by one. Okay, so this is group of 1, and this is group of 2, and this will be group of 3. And what we get as the third element here is the third group that we have here. What is matched? It is a bit mysterious because due to the greedy matching. So as you do more regular expressions, okay, especially in the industry or science research, you will become more aware of the unintentional behavior of the greedy matching. That's why we have an option to do the question mark after the quantifier. So they do greedy matching, and sometimes it is hard to understand what exactly it is doing. Basically, it pushes outward as much as possible to match the string. And therefore, it matches the entire thing. The only thing this can match is just one digit. It is sufficient. So this last digit alone matches this particular pattern. And this one does the greedy match till 202, the dot star. and therefore what is matched by the third group is just a 0. And if you look at this here, we put a space at the end, so 2020 will not be matched. It's only matching till 0, 1, and the last digit to be matched is just 1, and that is what is written. So that's an excellent question. And thanks for raising that question. Even I missed out to explain it or even notice it. Good observation and good question. I'm glad that question was asked. So is that clear to everyone?
Yes, sir.
So I hope that was clear to everyone. So this is like in the task script, there is a small extra element that you might observe. If you do observe, it will have you puzzled. And this is the explanation for it. Okay, so there are 3 groups and it's returning the third group. And the third group happens to be a victim of the greedy matching of the second group. So the third group is just 0, 1, and somewhere it is just a space. Okay, we can easily work it out why it is like that. All right, so now we are ready. Okay, are there any more questions? Okay, so let's do a.
Sir?
Yeah.
Sir, you said that is because of greedy matching, no, sir?
Yeah.
Dot means any character, star means 0 or more, so it will go till the end of 2020, no, sir? Why it is going only till 2 and that last internal parenthesis alone is executing 0 again?
Yeah. Let me explain that again. You see, all right. So this is where we have this. So dot star means basically how do we say it in words? What dot star is? It's a common construct, as I said yesterday. It basically means any character any number of times. Okay. So this will basically match throughout. But then the pattern also contains a digit. If you don't match the digit, then the pattern is not matched. So a digit has to be matched. So the dot star keeps the digit for the last digit. Okay, and this will match the last digit so that the pattern is matched because the pattern is matching. So the 0 will match this particular expression and the dot star will match till 202. But then the group is for the entire thing. So the whole group is returned and this group is just 0.
Okay, sir.
Are you able to follow?
Yes, sir.
Okay. Yeah, you think about it. It's a very interesting problem. Sorry?
If I write it down and again think means I can.
Yeah. Please do that. As I say, the group is matching the entire set here. So for the group, the entire set is returned. But what is the dot star matching? The dot star is matching till the 202. And why is it doing like that? Because this pattern has to be matched. This sub pattern has to be matched for the pattern to have a match with the string. So this sub pattern is matching only the 0. It is possible for 0 to match this sub pattern. And the rest of it is matched greedily by dot star. So only 0 is matching this particular group. And the rest of it is matching dot star because the dot star is greedy. Okay. But when the pattern is returned, the whole thing is within the second parenthesis. So the whole thing is returned. And what is within the third parenthesis? Only 0 is sufficient to match the third one. So the 0 is returned. That is how the matching is actually happening. All right, so let's do a problem today. So the problem we'll do today is we'll take a file of phone numbers, and phone numbers can come in different formats. We'll see that shortly. And using this file, we want to extract the area code from all the phone numbers. Okay. So let's say the phone numbers are 10 numbers long, and the first 3 numbers are usually the area code. But there are different ways to write the phone number, and that is why we must use a regular expression to extract the area codes. So let's prepare the input file first. Okay. All right, so what we are going to do is, all right, so let's write some phone numbers now. So let's say 044, and let's say 10 digits, so it'll be 11 digits, is it? That's fine. Let's say the area code is just 2, and then let's say 23. All right. Now, what is this area code? Anyone knows this area code?
Chennai, sir.
Chennai. Okay, good. So we're going to write a series. So this file is going to contain a series of phone numbers. And our task is to extract the area code from all these phone numbers. Read the file line by line and extract the phone numbers. Okay, this is one format in which the phone number is given. Here is another format, 80 hyphen. Is this format possible? What is this area code, anyone? No one knows what this area code is? Anyone? See, quickly, let's do this. We want to now apply the regex on these phone numbers. So what is the Bangalore? Okay. All right. Now give me some more area codes. What is the area code of your region?
Sir, 040, Telangana.
Okay, 40. Now let's say this 40 is in this format. Okay. It's possible, isn't it? Now one more area code, please.
Sir, 11 for Delhi.
11 for Delhi. Okay. So let's say 11 and then something like this. Okay. And then something like this. Okay, you see now how many different formats. All these are possible formats, correct? Okay, all these are possible. Okay, now any other code? Let's say 22 for Bombay. Anything else? Anyone knows Calcutta's code? 33, maybe, I don't know. Let's say 33. Okay. All right. So we have all these phone numbers. Now in the end, let's say 360p. Now this is not a phone number. Okay. All right. So this is what we have. And all right. So let us see now with respect to each of these phone numbers, when we want to search for the area code, what should be obtained? In this case, 44. In the second example, what should be obtained? Anyone? We should get 80. Third one?
40.
14. Then 11. And then 22. And then 33. And here, nothing should be captured, isn't it? Here, nothing should be captured. That is, the pattern should be skipped. It is not matching the pattern. So this line should be skipped. There is no area code in this line. Okay. So what we want to do now is to write, construct a regular expression for the phone numbers. That is the first task. Second task is to process the file and extract all the area codes. So as you saw in the first lecture on this topic, there are two parts to regular expressions. The hard part is first constructing the appropriate regular expression for the problem. The second part is writing the program to search using this regular expression and process some text file. So this is simple Python programming, which should be easy using our Python skills. But the first one requires this new skill, that is the regular expression formation. Okay, you should be able to construct the appropriate regular expression. So this is what we have. All right. So what we will first do is, let us first construct the regular expression. Okay, so construction of the regular expression. So what do you think is the appropriate pattern for this problem? Okay, so you say that, so this has to be captured. So this line has to be captured. This has to be a capture. And this has to be captured. This has to be captured. This has to be captured. But here, this should be skipped. Okay, this has to be skipped. Okay, skip this pattern. So, and what do we capture? It's 4, 4, 8, 0, 4, 0, 1, 1, 2, 2, and 3, 3. So these are the ones that we capture. We are trying to capture capturing the area code in the phone numbers. All right. So you see the problem arises because multiple formats may be used for the phone number. Okay, all these are valid formats. Sometimes we use just the area code in the beginning. Okay, sometimes we use brackets in the beginning. Sometimes we use a hyphen to separate the area code from the rest of the number. Sometimes we use the space to separate the area code from the number. Sometimes we don't use anything. We just give the entire number. Let's just say 442342 2344. We're not giving anything at all. Even here the 44 has to be extracted, isn't it? We're just giving the full number, and that has to be extracted as well. So now you see there are so many different patterns. Even if you just enumerate the number of possible formats here, right here we have so many different formats. So this is one, another format, another different format. So this is at least same as the 80, and this is a different format. So even here, if you see, there are 4, 5, 6 different formats are there just for the phone number. So now if you want to extract the area code, we can't do some simple string methods for this. String methods will be hopeless. What we want to do is construct a single regular expression that will be able to trap all these different phone number area codes. Okay, a single pattern that can match all the area codes that we wanted to match. So that is the idea, and that is the flexible pattern we want to devise. At the same time, the pattern should not match unwanted entries like 360P, which has a letter that should not be matched. Okay, so we don't want it to match other words that contain numbers along with some letters. That should not be matched. Okay, so this is the general idea of all the possible possibilities we have for this pattern, and taking this into account, we want the pattern to match everything that should be captured, and it should skip everything that should not be matched. Okay, so capture those we want to match and skip those we don't want to match. So both the things have to be satisfied. Only then it is a useful regular expression. Okay, it should skip what must be skipped. It should capture what must be captured. Both the objectives must be met. Only then it is a suitable regular expression. Okay, all right. So now the challenge is open. So let's see who can come up with the regular expression for this. Okay, so what do you think is a good regular expression for this? So let's post the problem. Okay, you can post a solution here. There is something activity we can do. Let's see what. Okay, just about questions. So let's say, okay, so construct your optimal regex pattern for the area code extraction in phone number listings. Let's say it's a file. Okay, so but now we just want to extract the area code alone. Okay, and post it here. Okay, so construct your optimal regex pattern for the area code extraction phone number listings and post it here. Okay, so why don't you all can have a chance at this. Let's see who comes closest to this. Okay, so the two objectives, what are the two objectives? Two objectives to be met. One is match, capture everything to be matched. Second is skip what should not be matched. All phone numbers that must be matched, you have to capture, and okay, what should not be matched must be skipped. Okay, so these are the two objectives. So why don't all of you try to do it? Okay, I'll give you maybe like let's say a couple of more minutes. Okay, before I start, and we'll again discuss it. So let's have 2 minutes for this. I want everyone to try. Okay, and construct a regex pattern that will at least match a few of these differing formats. Is the problem clear to everyone? Problem is clear?
Yes, sir.
Okay. All right. So take a couple of minutes. Okay, we'll wait. There's no hurry. Okay. If anyone has a solution, please post it here. Let's see who comes closest. Anyone has any solution? I don't see any responses yet. Looks like a tough problem. Someone should, surely someone has some pattern. No one wants to post. Is that it? All right, shall we discuss? Harini has posted. Could we write find all? Yeah, find all is a function. Okay, we are only talking about the pattern. Okay, so as I said, let us separate the problem into two parts. First, you construct a pattern. It's a separate problem. Then we apply the pattern for searching. That is the second part. Okay, so Nikita has given one expression. It is Let me just copy this expression and we'll discuss it. And there's another expression given by, yeah, Harini, please, I think backslash D of 2. Okay. So that is the digit. So in fact, it's a backslash D. Very good. That is for the digit. Okay, let's look at this as well. Okay, we have two answers, and let's see whether these two answers will satisfy or we have to improve upon the two answers. Okay, so let's take the first answer. It says starting with a number. Okay, and it starts with the number 0 to 9 and any number of numbers followed by a space. Okay, now what all will it match? Starts with a number, yes. And then it is matching till a space. So yes, this one is trapped by, I think, whose pattern is it? By Nikita's pattern. Okay, so this one is matched. Now the second one, starting with a number, correct. But there is no space at all. So this one is no. Now this one, if you see, starting with a number, it's not starting with a number at all. And this one again is not matched. Oops. So this one again is not matched. To take this, again, this is not matched because it's not starting with a number. This one, yes, it is matched and there's a space. This one starting with a number, but there's no space. So again, no for this. And this one starting with a number, yes, but space is at the end. So the area code is not extracted. So again, no. So, and this one will be skipped because it's starting with number ending with a space and only numbers should be there. And so this one is correct. We'll get the correct thing for this because this will be skipped because there's a letter here. So how many correct we have? 1, 2, and 3. 1, 2, 3, 4. There are 8 entries. Out of 8 entries, this pattern will match 3 out of 8. I mean, this pattern will work for only 3 out of 8 instances. It works for 3 out of 8 instances, which is a good first attempt. All right. All right. Now let's look at Vijay's pattern and let's explore this again. So we'll basically work out how it's going through, isn't it? Now it's 2 digits followed by not a digit or not an alphabet. Okay. But you see here it is 3 digits and then an alphabet. All right. But anyway, and we have 2 digits followed by non-alphanumeric character. Okay, so let's see this. So this one, yes, excellent. Second one, 2 digits and a hyphen, non-alphanumeric. So yes. Third one, there is 2 digits and a non-alphanumeric. It is correct. It is correct because he is not using a caret symbol. So it is not matching at the beginning. So therefore it matches the 40. And then it goes here, it sees a non-alphanumeric, so it matches that. Okay. Now, but if you have a space here, then it will also match the 65 because it is 2 digits followed by a non-alphanumeric. So when we know that it has to be at the beginning, it is better to always put a caret symbol, but then we have to account for the fact that we also have a parenthesis. So we'll think about how to do it. But let's see what is the next one he is given. So again, this one, yes, we'll say yes, but maybe because it is not the beginning. And again, this is also yes, and we'll say maybe. This is actually no. Actually, this will be a no. I'll tell you why. We'll just say maybe here. No, yes. Because this 1 will be matched. And then 7, 8 is 2 digits followed by alpha non-alphanumeric character. So 7, 8 will also be matched. Okay. So here both 1, 1 and 7, 8. Both of these will be matched. But 7, 8 is a false positive. It is not an area code. It is in the middle of the number. We don't want 7, 8 to be matched. So therefore we don't know. It gives a correct hit as well as a wrong match. Now this one, yes. Next one also yes. Next one is no. This one is no. Okay. You see this pattern, it is 2 digits followed by non-alpha numeric is not matching here. Now here again he says 2 digits followed by a non-alpha numeric, that is our pattern here. But here it is 3 digits and followed by a non-alpha numeric, but this is a numeric, so this won't be matched, and in that way it is also correct. Okay, because the third one is the digit, but the third one has to be non-alpha numeric, so in that way he is also able to identify this as a wrong match. He is able to identify this as a line to be skipped. That is good. All right, so how many has he got it right? So he's got 1, 2, 3, 4, 5, 6. 6 are 5 are completely correct, 2 are maybe, and 1 is wrong. Okay, so works perfectly. Let's say works well for 5 out of 8, maybe for 2, that is with false positives, and not for 1 instance. All right, is that clear to everyone? How we analyze the constructed patterns? Are there any more patterns? No more. Okay. So Harini had just given D of 2, and it's a similar analysis. Okay. D of 2 will match all the digits. 2, 3 will be matched. 4, 2 will be matched. 3, 4 will be matched. Everything will be matched. So just saying D of 2 is not useful. Okay. So that is why the string methods are not very useful here. Any simple pattern is not going to work here. Even this complex pattern he has given, that is not working for 3 of them, isn't it? Okay. So this is how we analyze whether the pattern works. We take the pattern and apply it to every line, to every example, and see whether the expected result is returned by the pattern or not. And we record it for every example. And finally, we see for how many examples it is working, how many is not working. From this, how can we improve the pattern? That is what we have to do. Now you see, this pattern works for 3 out of 8. This works for 5 out of 8. So maybe we can improve this and get a even better score. And finally, we should get 8 out of 8. That is what we should get. So any suggestions on how to improve this? So let's see where it is going wrong. That's how we analyze. So first is here. Okay. As we said, it may match. We have to put a caret symbol here, so it is matching at the beginning. And secondly, we have to match for a parenthesis at the beginning. Okay. So let's add the symbol to this expression. Now, the parenthesis is there in some numbers, it is not there in some numbers. Now, how do I match an exact parenthesis? How can I match a parenthesis? How do I actually match a parenthesis?
Sir, backslash parenthesis.
Backslash. The parenthesis is a meta character. It is used for grouping. If we want to match a parenthesis, we have to put a backslash. So let me put a backslash in the open parenthesis. But then you see the parenthesis is optional. It is not present in these numbers. It's only present in these two. So the parenthesis may be there or may not be there. So how do I indicate that? To indicate that, I just put a question mark. Okay. So as you saw in our notes, the question mark as a quantifier, it means either 0 time or 1 time. So here it is present 0 time, here it is present 1 time. So the question mark can be used. Now after the question mark, there will be 2 digits. The parenthesis is optional, but after that, you can have 2 digits. And that is what I want to extract. Since I want to extract it, I put it within parenthesis. Okay. Now after the digits, okay, so what I can have, okay, maybe anything. Okay, except that it should not be a alphabet. Now I've already extracted my pattern here, that is the 2 digits. I have matched at the beginning, I have accounted for the parenthesis, and I am matching for the 2 digits. Now after, what follows after the digit, okay, can be anything but a alphabet. Can be anything but an alphabet. Or we know that the allowed characters are space, another parenthesis, and hyphen. So what I can say is, I can say after this, it can be a space or close parenthesis. I mean, it can be a close parenthesis, and then it can be a space, can be a hyphen, and then it can be a number 0 to 9. Okay. All right. So when I use the hyphen here, this means a range. So if I want to use it separately, I have to use it here. All right. So now this is what I have, and this can be repeated any number of times, at least once. But in fact, can be for a few times. And this is the end of it. Yeah, this is the end of it. So this is what I have. I can put the close parenthesis within the brackets. That means I don't have to escape it. These are the set of allowed characters, and then the space, and then the hyphen, and then 0 to 9. So after I get the first area code, then these are all the possible characters. At least once, definitely. I mean, at least, like, let's say there are 8 digits here, so you must have at least 8 times, isn't it? So we can say 8, comma, because we can have any number of spaces between them, hyphens. All these will add to the number of digits. Okay. So what is the maximum number of digits you can have? You can have one close parenthesis, and then you can have a space or a hyphen, again a space or a hyphen. Okay. So if you look at that, 8 plus 3, 11 characters is the most. So you can say 11 here, but it doesn't matter because what we are matching is only the area code. We're only using this to discount those that we don't want to match, so that these things are not matched. Okay. So this is not a phone number at all, and if we specify this pattern, this won't be matched. So let's just say 8, comma, that means minimum 8 times. So this pattern is repeated at least 8 times. Whatever is here, any character from this set, at least for 8 positions, we have it. Okay. Now when we use this, you see what we are doing. It has to match at the beginning. So it's searching for the pattern only at the beginning. And it says the parenthesis is optional. And then we have 2 digits, and this 2 digits is within a parenthesis, is within a group, and this is extracted. So this is the area code we want to extract, and it is nicely extracted here. We just say group of 1 and it will be returned. And then it's followed by the rest of the phone number, and we are specifying the format for the rest, so that those that are false will not be matching this particular pattern. Okay, so we want to also skip those that are not phone numbers. So we also specify the rest of the pattern here. So if we apply this, then this will be matched because no parenthesis, first 2 digits, second one, first 2 digits. Okay, with the parenthesis is also matched, with the parenthesis also matched, 2 digits matched, 2 matched, 2 matched. Here 2 is matched, but the rest of the pattern will not match because this is what we have. There are no letters that are allowed here, so therefore this will be skipped. So the first 7 will be matched, and the 8th one will be skipped. So this one will give us 8 out of 8. This one will work for 8 out of 8 instances. Everyone agrees? Everyone agrees with this pattern? The important thing is just here. What we have here is the key part, where I'm escaping the parenthesis and then putting a question mark for the parenthesis because it is optional. Okay. Is this clear to everyone how we can just actually construct a pattern that will match the phone numbers, whatever the format may be? All of these phone numbers will match this pattern.
Sir, once can you say that 8, comma?
Yeah. After we get the area code, now what about the rest of the pattern? The rest of the pattern should not include any letters, so that we skip these particular false patterns. So for that, we are specifying the rest of the code. What it can be is, it can be a close parenthesis, because if you had an open parenthesis, can be a close parenthesis, it is allowed. Can be a space, because here we have a space. Can be a hyphen, because here we have a hyphen. Or it can be some numbers, because we must have 8 more numbers. Since we have a minimum of 8 more numbers, so this particular allowed set, it occurs for 8 positions, because minimum we must have 8 more numbers. So 8 is the minimum. It can be any number of times otherwise, because if you have parentheses and space and hyphen, it can be more number as well. So that is what we are doing here. It's for the rest of the phone number.
Okay, sir. Thank you, sir.
Yeah. Any other questions, anyone? All right. So now let's write. So this is the pattern. So this was the difficult part. I'm sure you'll all agree. Okay. So now let's try to write a program that will employ this pattern and process a file that contains these phone numbers and extract the area code from these file and print the area codes. Are you ready for that?
Sir, I have one clarification, sir.
Yeah.
Sir, basically, whenever we are given any problem like this, like even in work, wherever we work, suppose now we have constructed in such a way that if we want only the area code, we will type in group of 1. If we want even the phone number also, we'll type group of 2. So it's like not only just restricting the regex expression to only finding area code. If we want, we can get that second part of the number also, or the first part of the number also.
Absolutely.
So whenever we are trying to construct a regex, we have to like generally the mindset should be like it should solve all the problems, no sir?
No. I mean, that's not, I won't say it's a mindset that you must have like that, because to solve all problems may become like too difficult a task we are setting ourselves. And especially when you're working, you have a deadline and you have to complete the job. And if you're only asked to find the area code, we have to find only the area code. But now there is a reason why this part of the pattern exists. And let me repeat that reason. You're right, only this one will match the area code. But why does this part exist, and why did we create a proper expression for that, pattern for that? That is because we want to miss these particular patterns. These patterns should be skipped. Otherwise, we will be extracting 36 from here. How can we miss these patterns? Only if you complete the entire pattern, this pattern will be missed. Okay, because each hit, each match should match the entire pattern. After it matches the entire pattern, the part corresponding to the area code is extracted. So first we want to make sure it is a valid phone number. Now after we make sure it's a phone number, we are extracting the area code. And whereas where we look at this is not even a phone number, so therefore the pattern will not match. And even though it has 2 digits, the pattern is not matching, so it is skipped.
Okay, sir.
So what we are doing here is, we did not set out to actually parse every part of the phone number. The problem is only the area code. But then we are forced to complete the pattern so that we ensure that the pattern does not match some spurious instances in the data set. We do not want 360p to be a match for the D of 2. So if we specify that first has to be a valid phone number by specifying the full pattern, it first checks it's a valid phone number, and then from the valid phone numbers alone, it extracts the first 2 digits. So that is the logic. Now, if we want, we can also extract the full phone number. If we want, we can extract the last 8 digits. So all that is possible. They're all subsets, but we did not set out to solve a very big problem and then narrow it down into the area code. It is that to solve the area code itself, we have to have the full pattern at hand. That's how I will put it.
Yes, sir. Now I got it, sir.
Yeah. Okay. So when we have a lot of time, it is good to play with this regex. But when we are facing a deadline and you want to solve more problems within the deadline, I don't know. I would advise you to tackle harder problems than what is necessary. That is just my thinking, not an advice. But all right, so this is what we have. So let's go on. We just have 5 minutes, so let's try to write the program in 5 minutes. So I hope you're all ready for it. So what we will do is we'll say, I'm going to say file name is equal to get the input from the user. So I'm just going to do this in Notepad. So we're not going to run it. Okay, so we're just going to just type the program in the 5 minutes we have. So input, enter, file name of 4 numbers for analysis. Okay, so now I'm going to say file handle is equal to open file name, and let's open it in R and text mode. So text file. Okay, and now what we are going to do is we're going to say lines is equal to, let's assume that the file name contains the phone numbers, 1 phone number on every line. It may also contain some other instances on every line. Okay, so we have to check whether it's a valid phone number and then extract the area code. So line is equal to file underscore handle dot what? Anyone? I want to read the file, so what will I do?
Read lines.
Read lines, excellent. So read lines off. So now let me iterate over all the lines. So this returns the iterator lines. So I take for line in lines. Okay. So let me first import my RE library. Okay. So now we have to define the pattern as well. So let's say pattern is a common one. So I'll define it here. And let's say this is my pattern. Pattern is a string. The line is also a string. So for line and lines, okay. Now what we do is we say match object, isn't it? So match obj is equal to re.search. Can anyone tell me what is this re.search arguments here?
So we'll search for the pattern. PADD.
So what are the 2 arguments? re.search of what? Quickly, what? Add comma?
Lines.
Not lines, just line. Okay, we're iterating every line, isn't it? So we've read the file, we have every line now. So we want to find out on every line exactly what we want. So add comma line. Now, if there is a match object, we want to do the following. So we can just say if match object. If re.search did not match the pattern in the line, the match object will be none. So it has a Boolean value false. So if it's false, we have to go to the next line. We have to skip it. So I say if match object. So if the match object exists, it's not none, then we do the following. So there is a match now. So if there is a match, then what do I do? Print. What do I do? Print match object dot group of 1. Okay. And so now I can come outside of this print. Now I'll be here. And then I do this for every line. And that is the end. So this is the end of it. That's all is the code. Now, is this clear to everyone? We still have 1 more minute to go. That was a very quick program. Is this fine? Now we are reading line by line. We have constructed the pattern because we already did the analysis for the pattern. We have the pattern here. Now we have opened the handle to the file. We are reading the file line by line in the iterator lines. For every line, I'm doing a re.search with the pattern. Now, if there is a match object, then I want to print the group of 1 of the match object. And the group of 1 is basically the first parenthesis, that is the area code. So now we have the area codes printed. Okay, we already know this pattern will match all the relevant phone numbers. It will skip the irrelevant lines. So we know that the pattern works. So we search the line with the pattern. And if there is a match, otherwise the match object is none, it goes to the next line. But if there is a match, I want to print the first group. That is the one within the first set of parentheses. That is the area code. Is this clear to everyone?
Understood, sir.
It's a very simple program, isn't it? So now you see, after we have the pattern, the program is basically very simple. It's just some simple Python and knowing some regex syntax, functions and syntax and all that. Okay. So I'm going to post this for all of you and go over it and come for tomorrow's class. Again, we'll be doing another thing tomorrow. Okay, so be sure to review this and refresh this and come for tomorrow's class. On Monday, we'll be having an assessment on regular expressions. Again, a multiple choice assessment. It will be no fill in the blanks, just multiple. There may be one or two fill in the blanks, but it will be an assessment. So make sure you're reviewing all this. Okay. And you have the weekend to completely refresh what we have done as well. Monday we'll have a assessment. Now, is that okay with everyone?
Sir, only on regex?
Only on regex. We'll have it only on regex. Okay?
Okay.
Okay, all right. All right, thank you, everyone.
Thank you, sir.
Yeah. Any doubts, please post it in the classroom as usual. Okay.